this time. Test. All right, cool. So it looks like we are live. I'm gonna mute the live stream. And today we get a rare day. I'm gonna move the camera. No, it's fine, I guess. Today we are in rare air. I decided to, in this project of doing C++, oh, I forgot to edit the stream name. Today it is C++ root. Python data frames evil twin from CERN. Part 1. Setup. Done. All right, cool. Now that we have the, did it change? Come on. Oh yeah, C++ root, Python data frames, evil twin from CERN, part 1 setup. All right, cool. So essentially, yeah, that's what I was trying to do. I was trying to find like, essentially the project idea is called 90% of machine learning. And it's really just to like set up the programming environment that'll allow you to like easily work with data and plot it and show it to someone and they can say, ooh, histogram, right? That's pretty much what pandas and R data frames are for. And the thing is that, you know, if writing it in C++ gets you so much more of a space saver and lower execution time, it's so much worth it. Anyway, so I started looking into, or like Googled essentially for, you know, C++ data frame equivalent. And the first thing I found, will this pick up my new tab or what's going on here? New tab. Yeah, we can go with C++ data frame. And this is the first thing that comes up. We can click on it like I did. And it is this person who wrote this really nice, look, they tagged it with pandas. They have some trading strategies in it. That's a big popular use of data frames, right? Financial engineering, multi-dimensional data. They have a nice picture here, whatnot. And yeah, right? So they got a nice explanation, blah, blah, blah. Very cool. Yeah, and the claims they make here are substantial. Pandas process image at its peak is 105 gigabytes. The C++ data frame uses 56 gigabytes. I think that's huge. That is a big deal. Anyway, that's all nice and good. I spent some Googling around. Let's see if we can find it. Stack Overflow. Customize cookies, confirm my choices. Anyway, this person says that. Anyway, eventually I was pointed to Googling for C++ root. And, oh wow, that's cool. .CERN, they don't just hand out those URLs. So let's go to it. And how about that? Analyzing petabytes of data. Open source data analysis framework used by high energy physicists and others. I'm others. Anyway, blah, blah, blah. Statistically sound. You can do exabytes of data. It's high performance. It works on Linux. This blew my mind. A C++ interpreter? I didn't know heaven existed until now. It's an exaggeration, but yeah, that's really cool. Anyway, so now that we're a couple minutes in, let's try and set this up. And the cool thing about it is that setup was incredibly smooth. I'm running Ubuntu 20.0 something. But anyway, yeah, this doesn't come up. Okay. The only thing you really need to install it is like the most zero basic understanding of Ubuntu. Anyway, let me bring up this window. No, that didn't do anything. Ah, there it is. Okay. Anyway, so all you do is you open a terminal and you write, I thought I had copied it, bear with me. Paste. Sudo snap install root framework. That's all you need to do. You hit enter, you type your password, and mine says already installed. Your install will probably take a couple minutes, but it does not get simpler than that. And as proof, I'll show you. All you do is type root, and you are in. On. Let me fix this layout. Yeah. Anyway, you are in the root interpreter, the C++ interpreter, which I think is really cool. And we can, let's see if we can get someone in the chat. 1 second. Go to my channel, online. Oh, someone that is now following me, Hoss00312. Thanks for the follow. And yes, I know I'm live. How do I give someone the link? Oh, right, someone that is now. Let's see. I hope is. I don't even know if anyone's watching this or if someone just randomly subscribed. Streaming for one viewer. All right. Well, anyway, what I really wanted to do was let's just like go through more. All right. Let me bring it up over here. Pretty much what I want to do is get started, right? I think that's an admirable goal. And we'll probably make this a little bigger. That's pretty good. Yeah. On behalf of all developers, contributors, and user community, welcome to Root. The Root Beginner's Guide, aka Primer, is certainly the first document to read to master the power of Root. The manual introduces you to the main parts of Root. After this introduction, tutorial presentations and video offer a different, more direct approach to the Root fundamental concepts, as well as some hands-on exercise. In order to integrate the information present in the aforementioned sources, the collection of Root courses is definitely useful. Once the useful concepts have been acquired, a rich set of tutorials are available to dive into the code. Let's see what they call these rich tutorials. Histograms, graphs, graphics, and trees. Noted. Anyway, Remember, you can always resort to the root forum to find out if someone already solved the problem you are facing or to get help. Well, that's great news. There's probably a lot of smart people on there if it's linked up with CERN, right? Okay, so I think we should start with the beginner's guide, aka primer. And you know, I did not plan this out too well in terms of my layout. I'm just looking at that screen for reference. We might have to do some resizing in a bit, but let's see what we can do. Let's just read, and then when we get to something important, we can fix the sizing. Anyway, let's look at this. Come on, where's my big font at? There we go. Beautiful. Root is a software framework for data analysis and I/O, a powerful tool to cope with the demanding tasks typical of state-of-the-art scientific data and analysis. Among its prominent features are an advanced graphical user interface ideal for interactive analysis, an interpreter for the C++ programming language, and rapid and efficient prototyping, and a persistence mechanism for C++ objects. Beautiful. Used also to write every year petabytes of data recorded by the large, however you feel like saying that, collider experiments. This introductory guide illustrates the main features of Root, which are relevant for the typical problems of data analysis, input and plotting of data from measurements, and fitting of analytical functions. Here are the original authors. Motivation and introduction. Welcome to data analysis. Comparison of measurements to theoretical models is one of the standard tasks in experimental physics. In the most simple case, a model is just a function providing predictions of measured data. Very often, the model depends on parameters. Such a model may simply state the current I is proportional to the voltage U. Excuse me. And the task of the experimentalist consists of determining the resistance R from a set of measurements. Okay. As a first step, a visualization of the data is needed. Next, some manipulations typically have to be applied, e.g., corrections or parameter transformations. As a first step, a visualization of the data is needed. Next, some manipulations typically have to be applied, corrections or parameters to the transformations. Okay. Quite often, these manipulations are complex ones, and a powerful library of mathematical functions and procedures should be provided. Think, for example, of an integral or peak search or a Fourier transformation applied to an input spectrum to obtain the actual measurement described by the model. One speciality of experimental physics are the inevitable uncertainties affecting each measurement, and visualization tools have to include these. In subsequent analysis, the statistical nature of the errors must be handled properly. As the last step, measurements are compared to models, and the free model parameters need to be determined in this process. See Figure 1.1 for an example of a function model fit to data points. Several standard methods are available, and a data analysis tool should provide easy access to more than one of them. Means to quantify the level of agreement between measurements and a model must also be available. Is this one that they're talking about? Measure data points with error bars and fitted quadratic function. Very nice, very pretty. Cool. Quite often, the data volume to be analyzed is large. Think of fine, granular measurements accumulated with the aid of computers. A usable tool, therefore, must contain easy-to-use and efficient methods for storing and handling data. In quantum mechanics, models typically only predict the probability density function, PDF, of measurements depending on a number of parameters, and the aim of the experiment analysis is to extract the parameters from the observed distributions of frequencies at which certain values of the measurements are observed. Okay? Measurements of this kind require means to generate and visualize frequency distributions, so-called histograms, and stringent statistical treatment to extract the model parameters from purely statistical distributions. Simulation of expected data is another important aspect in data analysis. By repeated generation of pseudo-data, which are analyzed in the same manner as intended for the real data, analysis procedures can be validated or compared. In many cases, the distribution of the measurement errors is not precisely known, and simulation offers the possibility to test the effects of different assumptions. Excuse me. A powerful software framework addressing all of the above requirements is ROOT, an open source project coordinated by the European Organization for Nuclear Research, CERN, in Geneva. ROOT is very flexible and provides both a programming interface to use in own applications and a graphical user interface for interactive data analysis. The purpose of this document is to serve as a beginner's guide and provides extendable examples for your own use cases. Based on typical problems addressed in student labs, this guide will hopefully lay some of the ground for more complex application in your future scientific work, building on a modern state-of-the-art tool for data analysis. This guide in form of a tutorial is intended to introduce you to the ROOT package. This goal will be accomplished using concrete examples according to the learning by doing principle. And because of this reason, this guide cannot cover all the complexity of the ROOT package. Nevertheless, once you feel confident with the concepts presented in the following chapters, you'll be able to navigate through the reference guide to find all the details you might be interested in. You can even look at the code itself, since ROOT is a free open source product. Use these documents in parallel to the tutorial. The ROOT data analysis framework itself is written in and heavily relies on the C++ programming language. Some knowledge about C++ is required. Okay? Just take advantage from the immense available literature about C++. If you do not have any idea what this language is about, ROOT is available for many platforms: Linux, Mac OS X, Windows, but in this guide we will implicitly assume that you are using Linux. Like I said before, I'm running Ubuntu. The first thing you need to do with ROOT is install it, don't you? Well, you need to, yeah, okay. Obtaining the latest ROOT version is straightforward. Just choose your preferred installation method from the install page. You will find pre-compiled versions for the different architectures or the ROOT source code to compile yourself. Just pick up the flavor that you need and follow the installation instructions. Let's dive into ROOT. Woo! All right, looks like we're going to start typing some code. So I'm going to try and change up this layout. Which I did not prepare for in advance. So let's take a sip. And what's going on here? Oh, okay. Here we go. excuse me. So let's put this a little bit behind my head and kind of shrink it a little and maybe make it, no, not that way. We can make it, can we make it go up? Let's do, this is obviously super entertaining for everyone watching, I'm sure. I'm so sure they're super entertained. Anyway, okay, move that there. Grab it here. Move it around on the stream. And then we want to shrinky dinky a little. And I think that is, I think that's adequate. I think we have a setup here. I'm going to take another sip. And then, as you can see, let's actually make the tutorial a little bit bigger of a font for you. Oop, what did I do here? I just went up a little bit more. Let's see. How about, yeah, I think that's nice and big, nice and legible. Okay. Root as a calculator. You can even use the root interactive shell in lieu of a calculator. Launch the root interactive shell with the command root. Oh, I was already in it. Oops. Oh yeah, I typed it up here. I didn't even realize that. Anyway. On your Linux box, the prompt should appear shortly. Over there. We got an error. Now we're going to be 1 off. Actually, let's just quit it and let's just root. We're in. All right, let's do some adding. 1 plus 1 here. Very complex. Integer 2. Now we got some multiplication and let's see, some addition and some division with a dot. That gives us a double, probably because we're using a double for that 12. All right, we got a SQRT of 3. We got a 1.7. 73 to 05 08. Okay, cool. Is 1 greater than 2? It is not. Ooh, we got tab complete. That's awesome. Tmath, : pi. Who doesn't love pi? That's rounded. Wow. Anyway. And we can do tmath. Oops. Dot. Is this the error function? Ooh, excuse me. Anyway. Not bad. You can see that root offers you the possibility not only to type in C++ statements, but also advanced mathematical functions which live in the tmath namespace. Now let's do something more elaborate. A numerical example with well-known the well-known geometrical series. Ladies and gentlemen, we're about to implement a geometric series here in root. Can I actually, if I knew how to make clips in Twitch, this would be one of them. Anyway, so we want a double, we'll call it X, and we'll make it 0.5, right? And we want an integer, we will call it N, and we want it to be 30. We want a geometric series, we want a double, GEOM, series equals 0. Beautiful. I love how it tells us what the thing is. This is very similar to many interpreters that I've worked with. Oops. And it looks like we're about to just write a for statement completely inlined. For int I equals 0, very old school here. I is less than n. Ooh, a little bit of that kind of increment. GEOM. Oh, yes. Series plus equals T math colon power x comma I. I guess since it's a one-liner, you do not need curly braces around it. Okay. I guess that means series is now 2. What? Okay. Anyway, C out. T math. Colon. Abs. Geom series minus 1 minus T math. Colon power x comma n minus 1, 2 brackets, the division symbol. That's a long line. Divided by open brackets 1 minus x, close those brackets, and L. We get some very small number. Did they get a small number? Yeah, they got a small number also. Awesome. So here we made a step forward. We declared variables and used a for control structure. Note that there are some subtle differences between Cling and the standard C++ language. You do not need the semicolon at the end of a line in interactive mode. Try the difference, e.g. using the command at line root 6. Yeah, whatever, I believe it. Anyway, learn C++ at the root prompt. Behind the root prompt, there is an interpreter based on a real compiler toolkit, LLVM. It is therefore possible to exercise many features of C++ and the standard library. For example, in the following snippet, we define a lambda function, a vector, and we sort it in different ways. This is huge. This is phenomenal. This is a great example. And over here, we're going to quit, and we're going to clear. We're going to start our root renumbering, and yes. So it looks like we're doing a type def here, or something of it. I forget exactly what that is. Is this? I've never used using like this. I think this is, I guess, just so we can do doubles instead of having this big long, having to do a vector type double all the time. Cool. That's very neat, actually. Standard vector double. Yeah, that makes everything neat. Anyway, auto keyback, all right, equals, this is the C++ has lambdas, but they are literally the most bonkers of like every other language. Like the lambda is the most simplest construction, but C++ takes the cake over here. Count doubles Doubles. Ampersand. Okay. Okay. It's a vector of doubles. Okay. Okay. Anyway. Auto and x in v C out x endl. Okay, so first off, let me get rid of this 7. I have no idea what this is. We made a lambda called vector. I honestly forget the syntax for lambdas, but obviously it's doing for x in v, just print x. Oh, here's v. We're saying a vector of doubles. So this is a print vector, I guess. And do we type it right? No, we did not. Unknown type name count. Unexpected. Okay, I got something wrong. Oh, I forgot my opening brace over here. Nope, that still did not do it. I could copy and paste, but I don't want to. All right. Auto pvec equals brackets. Open paren. Oh, constant, not count. Put a like or comment down below if you caught that mistake before I did. C out. Bro, what is going on here? For auto. Okay, I could believe this one. Hey, it runs. Awesome. Anyway. Let's make a vector called doubles of v 0, 3, 5, 4, 1, 2. Cool. But if you put a semicolon, it suppresses it. All right. So if everything is going according to plan, we should just be able to print this vector. And it does print that vector. Awesome. And we can, let's scroll back to the beginning here. There you can see. And we can do standard sort. Okay. v.begin. v.end. Awesome. And we'll print it again, and we see that it is sorted from beginning to end. And let's see. Ah, yes. The lambda has come to visit us again as a third argument to standard sort. Right. Lambda, and we're going to take a double A and a double B. And then we're going to open some brackets here. And I'm going to return A is greater than B. Semicolon. Bop, bop, bop. And we're going to print that vector and see that it has been reversed. Okay. Or if you prefer, random number generation. Let's go. Standard. Default. Random. Random engine generator. Standard. Normal. Distribution of doubles. Distribution 0 dot comma 1 dot semicolon. Did we type that right? Okay. Distribution of generator. Okay. And if we call it again, oh, we're seated exactly the same. That's pretty cool. Or close enough, you know. Impressive, isn't it? Bro, relax. Root as a function plotter. Here's where we really hit the, like, we're replacing Python because C++ is much faster and types are so much worth the time. Anyway, root as a function plotter. Using one of root's powerful classes here, tf1, will allow us to use a display function of one variable x. Try the following. Right. This is the big tell f1. And we're going to name this f1, I guess. And we're going to do sine of x divided by x as a string, 0 dot, comma, 10 dot. And did that work? All right, it takes a little time. F1 dot draw. This does not show up on the live stream. Give me 1 second to make this incredibly impressive. Window capture device. Okay. C1. Now here's, you guys don't get it yet. First off, let's make this as big as the screen, but let's not forget I am the main character of this presentation, not this graph. Let's just make it a little bit smaller so you can see that 10. Perfect. Anyway, this just popped right open. That's fantastic. You can move it around. That's pretty impressive. And if you go to options, oh, it's not showing you the options. That's sad. Toolbar. What do we got here? Line. Let's just walk through them. I don't know what they do either. New, open, print, interrupt, refresh, inspect, browser, modify, arc, line, arrow, diamond, ellipse, pad. What does it say? Pave. Pave label, pave text, paves text, graph, curly line, curly arc, text, LaTeX, marker, graphical cut. Let's draw an arrow. Oh, look at that. You can just be like, hey, All right, let's see. Can we just add text here? That, okay. Can I get rid of that? Oh, okay. So when you type enter, that thing goes away. Oh. What happened here? Did I lose my mouse? Yep. So I'm going to just say it's a peak. And now I can drag it. Can I grab this arrow again? Whatever. Anyway, as you can see, it's like a pretty full-featured thing. Where do I have a zoom here? I swear there was a zoom. I'm just not hip to it. But there, yeah, I think just being able to draw on it, that's pretty cool. Let's add a pad. Oh, what is this? Okay, there's a blank. Is it a peak? Yes. Oh, and that's another thing that's pretty nice. When you're moving around an object, it gives you like the things from like when you're doing Microsoft PowerPoint, it tells you they're equidistant from each other. That I thought was pretty cool. Anyway, let's continue on with the tutorial here. F1 is an instance of a TF1 class. The arguments are used in the constructor. The first one of type string, that's this F1, is a name to be entered in the internal root memory management system. The second string type parameter defines the function here, sin x over x. And the two parameters of type double define the range of the variable x. Okay. Interesting. The draw method, here without any parameters, displays the function in a window, which should pop up after you typed the above two lines. That's exactly what we saw. Awesome. We're out of focus. All right. I think I'm in focus now. If not, what does it matter? I'm just here to guide you. Anyway, the draw method, no parameters, displays the function in window. All right. A slightly extended version of this example is the definition of a function with parameters called 0 and 1. And so on in the root formula syntax. Okay. We now need a way to assign values to these parameters. This is achieved with the method setParameters, where you give it a parameter number and a parameter value of class TF1. Here is an example. Awesome. Let's make it happen. TF1 of F2. Okay, let's see if we remember here. The internal name to the root memory management system. Okay. Then we're doing, let's make these quotes. Argument 0 times sine of argument 1 times x in parenthesis divided by x, and we're going to go from 0 to 10. Now let's set these parameters. Set parameter of 0 to 1. I can dig it. Set Okay. Parameter number 1 to also be 1. Okay, this is pretty interesting. And then we're just going to call f2.draw. Let's see, well, I have to... No, okay, cool. Remember. So this is like the default size that it kind of opens up to, pretty small. Kind of like Matplotlib. But as you can see, we can extend it out, and it's exactly the same plot that we plotted before, except this time it shows you we have variable numbers here. It does not tell you what we've chosen for this simulation, but in any case, it works. So, you know, it's good enough for me. Anyway, of course, this version shows the same results as the initial one. Yes, I noticed. Try playing with the parameters and plot the function again. Okay. Let's make parameter 1, 4, and parameter 0, 7. Let's draw this baby again. Okay. Cool. Yes, I believe that this works. Okay, CERN. You win this one, I guess. The class TF1 has a large number of very useful methods, including integration and differentiation. To make full use of this and other root classes, visit the documentation on the internet. There. Formulae in root are evaluated using the class T formula, so also look up the relevant class documentation for examples, implemented functions, and syntax. You should definitely download this guide to your own system to have it at your disposal whenever you need it. To extend a little bit on the above example, consider a more complex function you would like to define. You can also do this using standard C or C++ code. Consider the example below, which calculates and displays the interference pattern produced by light falling on a multiple slit. Please do not type in the example below at the root command line. There's a much simpler way. Make sure you have the file slits.c on disk and type root slits.c in the shell. This will start root and make it read the macro, quote unquote, slits.c, i.e., all the lines in the file will be executed one after the other. So let's just quickly look over this. Example, drawing the interference pattern of light falling on a grid with n slits and a ratio r of slit width over distance between slits. Okay. AutoPy, single function, slit 0 function, n slit function. This is the main program. We ask for a number of slits and a slit width, and they return the R, I guess, whatever. Anyway, they make an FN list, so we're calling it FN slit. This variable right here is our equation, right? And slit, okay, so I guess you can either specify it as a string or pass it as a function. That's pretty cool, right? And we're gonna take it from negative 5.001 to 5, 2, I don't know. Anyway, we're making one and we're setting npx to 500. We'll find out, I guess, what that does. Anyway, set parameters as above, and draw the interference pattern. Draw it. Okay. Challenge accepted. Copy. Let's go here. Let's make a new file, and they want me to call it slits.c. All right, looks good to me. It's all saved. Let's go back to the root terminal. Let's quit out of here. And let's go back up to, and they said to just run root slits.c. Oh, they use a capital C. Let's follow their convention. Okay. Processing. All right, hold on. Let's close that. Processing slits.c. Slit with G, and we saw that. That's pretty much in the code here. So all right, parameters with parameters, let's see, 0.2, number of slits, 2, and we have our interference pattern. And you know what? I'm going to go ahead and say I do think this indeed looks like their interference pattern. Okay. Anyway, oh yeah. See, on their online version, right, this is what we're going to hopefully get to at some point. It's in a browser. It does this. You can zoom with the mouse wheel. You can do that sort of thing. And then there's this neat menu here that lets you do all this cool stuff. Put it in log if you prefer. There's that button, which I think makes it full screen. You can take a PNG, you know, very full featured. And so I think that's pretty cool. Anyway, the example first asks for user input, namely the ratio of slit width over slit distance and the number of slits. After entering this information, user should see the graphical output as shown in figure 2.1. We did that. Great job, us. This is a more complicated example than the ones we have seen before, so spend some time analyzing it carefully. You should have understood it before continuing. Let us go through it in detail. Bet. All right, let's pull this up over here. So we can, and we copied their line numbers, so we can just like look back and forth. All right. Lines 7 through 18. That's these, our little functions. Define the necessary functions in C++ code, split into 3 separate functions as suggested by the problem considered. The full interference pattern is given by the product of a function depending on the ratio of the width and distance of the slits, and a second one depending on the number of slits. More important for us here is the definition of the interference of these functions to make them usable for the root class TF1. The first argument is the pointer to x. The second one points to the array of parameters. Oh, true. The main program starts at line 21. Okay, yes, that's true. This is the main program. With the definition of a function slits of type void. After asking for user input, a root function is defined using the C-type function given in the beginning. We can now use all methods of the TF1 class to control the behavior of our function. Isn't it nice? Isn't it? Yeah, it is. All right. If you like, you can easily extend the example to also plot the interference pattern of a single slit using the function double single, or of a grid with narrow slits, function nslit 0 in TF1 instances. Say what now? Nslit 0. All right, here we used a macro, some sort of lightweight program that the interpreter distributed with root cling is available to execute. This is a rather extraordinary situation since C++ is not natively an interpreted language. Extraordinary situation, perfect words. That truly describes this. There is much more to say. Chapter is indeed dedicated to macros. Let's see, how much do we have left on this tutorial? Where's my little scroll bar? Let's see, we got controlling root. Oh, we got a plot. Do I have example data? Okay, so I don't have example data. So we'll just cover this controlling root, and we'll call that the tutorial for the day. Setup. Yeah, I guess this is a good setup. Cool. Anyway, controlling root. One more remark at this point, as every command you type into root is usually interpreted by cling, and escape character is needed to pass commands to root directly. This character is the dot at the beginning of a line. If you don't understand what this means, it's essentially saying we need a way to tell this program what to do instead of executing C++ code, right? And typically, starting a line with a dot is not allowed in C++, so they made it the special escape character here. Anyway, this is a selection of the most common commands. To quit, you just do .q. A list of commands, you can do question mark, so let's just do that here, question mark. Beautiful, I like this. Very, very, let's see, we got a file name or library, same as .l. And return and runs a function with signature, blah. Interesting. Anyway, redirects to a given file, standard out stream, blah, blah, blah. Undo. Interesting. Unloads the given file, shows the include path, optimization level, not yet implemented. It's cutting edge stuff. Prints out a class name. Int file statistics, prints out file statistics, information about a global variable, cancels or ignores multi-line input, raw input, scopes, stats. All right. Anyway, execute a macro with .x for execute. You'd have used .x slits.c. Load a macro with .l. Okay, in the above, you might have instead used .l slits before and then followed by a function called slits. Note that after loading a macro, all functions and procedures defined therein are available in the root prompt. Compile a macro. Type .l blah. Root is able to manage for you the C++ compiler behind the scenes and to produce machine code starting from your macro. One could decide to compile a macro in order to obtain better performance or to get nearer to the production environment. That's really cool. So let's quit. Or we know .l slits.c, and I just do a plus sign here, it looks like. Error. Error. Okay. Not too sure what that plus is. Not found. Okay. Well, I'm sure we'll come back to this at a certain time when it's right. Or we'll learn more about setting up our path. Something to look into. Anyway, I think that's it for today. Thank you for joining me on my ride. Whoever subscribed, I appreciate it. And please subscribe if you're watching and you haven't. Give it a like, leave a comment, reach out to me. Let me know what you're thinking. Anyway, have a good rest of your whatever.